Hello and welcome to Chemistry with Dr. Clark. In this video, I would like to talk about how to represent atoms using Bohr diagrams. In the Bohr model of an atom, Bohr envisioned the protons and the neutrons living in the nucleus, and then he had envisioned the electrons moving around the nucleus. Now he had said that the electrons were only allowed at very specific distances from the nucleus, and he called these orbits or shells. So if you look at my diagram here, right in the middle, this would be my nucleus. So here in the middle, this is where my protons and my neutrons would live. These rings represent specific distances from the nucleus where the electrons are allowed to exist. Now each ring is allowed to have a very specific number of electrons. Okay, in the first orbit or the first shell, the first ring, this one here closest to the nucleus, you're allowed to have 2 electrons. So 1, 2. In the second orbit or the second shell, the second ring, this next one out from your nucleus, you're allowed to have 8 electrons. Maximum is 8. So 1, 2, 3, 4, 5, 6, 7, 8. In the next orbit or shell, the third one here, you are allowed to have, again, 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Now, you don't have to have a full 18 electrons, right? What I've drawn here is 2 in the first ring, 8 in the second ring, 8 in the third ring. So I put in a total of 18. If you have less electrons, you will start filling from the middle and you will work your way out. But once you run out of electrons, that's when you stop drawing your little dots to represent electrons. Now, one of the drawbacks of Bohr and Bohr's diagrams is that they really only work well for the first 18 elements. If you attempt to draw Bohr diagrams for elements that have more electrons, you tend to run into some problems. So really, when you're asked to do these, it is most likely that it'll be for the first 18 elements. So let's take a look at some examples. If we start off small, let's talk about element number 1, element number 2, element number 3, and element number 4. So on your periodic table, if you are element number 1, you are hydrogen, and element number 1 means that you have 1 proton. Now atoms are electrically neutral. So if you have 1 proton, then you have to have 1 electron to balance it. If you have only 1 electron, that 1 electron will live in the very first ring, and there's your 1 electron. So the Bohr diagram would have the 1 proton in the nucleus and the 1 electron circling around it. Okay, let's say we move on to helium. Helium is element number 2. So if you're element number 2, that means you have 2 protons in your nucleus. It means that you have 2 electrons. The number of protons and electrons have got to balance out. So in this very first ring, you can fit a maximum of 2 electrons. You have 2 electrons, and so we can put those 2 electrons in this first ring, this first orbit. Easy peasy. If we move on to element number 3, lithium is element 3. It has 3 protons, so let's draw 3 protons in my nucleus. Atoms are electrically neutral, so if you have 3 protons, you have to have 3 electrons, 3 of each. So when I'm putting my electrons in, the very first electrons will go into the ring, the orbit, that's closest to the nucleus. So I can put my first electron here. I'll put my second electron in this ring as well. Now the problem is, that very first ring, the very first orbit, the very first shell, can only hold 2 electrons. So after I put my first 2 electrons there, this ring is filled. That means my third electron has to go into the next ring, because the first inner ring, first orbit, is completely filled with 2 electrons. The third one has got to go into the next ring out. Okay, if we move on to boron. Boron is element 4. It has 4 protons. That means it has 4 electrons. I'll put the first 2 electrons in the first ring, as close as possible to the nucleus. But that's only 2. That means I've got 2 more left over. Those next 2 have to move into the next ring out. Now this second ring can hold 8 electrons, right? I could put 8 in this ring, but I've only got 2, so I put the 2 in and that's where I stop. All right, let's say we move on to some things that are larger. Let's say we want to talk about fluorine. Fluorine is element number 9. That means it has 9 protons. If you have 9 protons, that means you have 9 electrons. The first 2 electrons go into the first orbit. So I just used up 2. That leaves me with 7. This second orbit, this second ring can hold 8, but I've only got 7 left over. So because I only have 7 left over, that's what I'm going to put in this orbit. 1, 2, 3, 4, 5, 6, 7. You can see that there's space there for number 8, but I've run out of electrons. I had 7, and I've put all 7 in that ring. Now, when we move on to neon, number 10, you have 10 protons, which means that you're going to have 10 electrons because you're electrically neutral. First 2 go into the first orbit. So I just used up 2, leaves me with 8. Well, now that's perfect. This second orbit, this second ring can hold 8 electrons, and I have exactly 8. So I can put that 8 electrons right here. 3, 4, 5, 6, 7, 8. 2 in the first orbit, 8 in the second, and that gives me a total of 10. Now, what happens if you have more than 10 electrons? Let's say we move on to sodium, which is element 11. If it's element 11, that means you've got 11 protons, but it also means you've got 11 electrons. I can put 2 in the first orbit, the 2 in the first ring. So subtract off 2 leaves me with 9. The second orbit or ring can hold 8, but I've got 9. I've got too many. So let's put in 8. 1, 2, 3, 4, 5, 6, 7, 8. So I've just put in 8, and that leaves me with 1. Now, if the first ring is filled and the second ring is filled and you've still got 1 electron left, that means you have to move to the next ring. This next ring can hold 8, but you've only got 1 electron left. So let's put 1 there. Okay, if we move on to magnesium, you can see where this is heading, right? When you had 11, you ended up with 1 electron in this outermost ring. When we go up to 12, that's going to give us 1 extra electron, so you're going to expect 2 in the outermost ring. So, magnesium is element 12. That's 12 protons. Means you got 12 electrons. Let's put 2 in the first orbit. So I used up 2 and I'm down to 10. The second ring can hold 8, but I've got way more than 8. So let's put 8 in. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I just put in 8. You've got 2 electrons left over. The first 2 rings are completely filled, so you have to move them into the outermost ring. So let's put them here, 1 and 2. All right, let's say we go to the limit. I had said at the beginning that this really only works for the first 18 elements. So we started off with the elements that had very few electrons. Let's go up to elements number 17 and 18. So if you're a chlorine, you've got 17 protons. That means you have 17 electrons. Let's put 2 in the first orbit. So we've just used up 2. That leaves me with 15. The second ring or orbit can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. So I've just used up 8 more. That leaves me with 7. And this third orbit can hold 8. I can put 8 there, but I've only got 7 electrons left. So let's put in 7. 1, 2, 3, 4, 5, 6, 7. And you're done. 2 plus 8 plus 7 is 17. You do have space for 1 more electron, but you didn't need to use it because you have all of your electrons shown, right? 2 in the first, 8 in the second, plus 7. That gives you 17, and that's all of them. When we move to argon, though, now we have 18. This is going to fill all 3 of those rings, right? I've got 18 protons in the nucleus. That means there's 18 electrons. I put 2 in that first orbital, so that's 2. Leaves me with 16. I'm going to put 8 in the second orbit, second ring. So if I put 8 there, that leaves me with 8. And this third orbit, this third ring, can hold 8. That's it, maximum. And I've got 8. So 1, 2, 3, 4, 5, 6, 7, 8. And all of my orbits, all of my rings are completely filled. Now, for this model, the reason why we don't go any farther is because the real rule is that this third orbital can hold 8, and sometimes it can hold 18, right? So when you have that extra electron, if you're going to talk about element number 19, the question is, do I draw another ring and put my electron in it, or do I squeeze my extra electron in the third ring? And it depends on which element you're talking about. So this whole model becomes a little more messy when you get past element 18. And that's why we've decided that we're going to just restrict ourselves to the first 18 elements, because it works best that way. Now, I do have another video that talks about how you would use Bohr diagrams to predict ionic ionic formulas for compounds. And I have a video that talks about how you use Bohr diagrams to predict charges on ions. If either one of those are something that you're interested in, please take a look at them. And as always, thank you for joining me here at Chemistry with Dr. Clark.